just like the previous question, I'm going to do the formula first. I'll do first principles second. Okay. So, being that I'm using the formula, and the formula for the sum of a GP, actually sum of any series, has ends in it, the very first thing I ought to probably do to help me out is rewrite it with a different letter, yeah? So I'm just going to call it 3 to the k minus 1. Okay, all sweet. All right, now using the formula, let's just quote that first. Which form should I use? I can go 1 minus r to the n, or I can go r to the n minus 1. What would you use in this case? I think you go 1 minus, right? Why?
Because each one is being divided by...
Good, that's right. The ratio is smaller than 1. It's not negative. Yeah, it feels like that, isn't it? Because things are getting smaller, right? So the ratio is... What is it, actually? It's a third, right? Good. So I'm going to use this form. Okay? Let's start putting some data into here. First term is equal to... Okay? We already just decided that the ratio was a third. Okay? So I'm going to put that in there. Now, we labored over this before. Let's see if we can apply a different logical process to work out. How many terms are there here? Now, think about this. Excuse me. Let me try and, without writing it out so much, but trying to apply some logic, right? From here, 3 to the n, right? What am I doing? I'm sort of counting down, aren't I? Right? I'm counting down to eventually, I'll get from 3 to the n, I'll get down to 3 to the power of 1. Okay? Now, how many terms is this? This is n terms, right? I mean, it's backwards, but it's still the same. It'd be just like if I were counting up from 1, 2, 3, 4, 5, 6, 7, n. Okay? So this is n terms. Now, I'm going to skip a term for a second, because then it goes from 3 to the minus 1, and it goes down to 3 to the, eventually, minus n. How many terms are there from minus 1 to minus n? Answer? N terms. Then you go one more time. Now, can you see, by the way, I'm not dividing it up arbitrarily. I'm trying to look for chunks or sections where I know exactly how many terms there are, right? What's immediately after 3 to the minus n? I'm decreasing, right? What's the next term? Minus n minus 1, right? Then I'm going to go all the way to the end, which is 3 to the minus 2n. Yes? How many terms? These two are equivalent, aren't they? Right? I could factor out the 3 to the minus n like we did before, right? There and there, right? Can you see what I've done? Right? So the number of terms from here to here is the same as here to here. They're really the same kind of length, right? Is in terms. Now, I said I left one out. What did I leave out? Which term did I leave out? 3 to 0, or 1, right? Where does it fit? It fits in right here. Okay? So, sorry, I did this all in n's. I really should be talking k's. How many terms are there? 1, 2, 3k plus 1. Okay, now, on the bottom, 1 minus the ratio, which is a third. So there's all my substitution. Let's just work this out. Okay? On the top here, I can do something to make this easier for me, right? That a third, it's better if I put it on the same base, isn't it? Because then that can talk to this, and so 3 to the minus 1 is better. Right? 1 minus 3 to the, now the minus 1 will interact with that, will multiply, so this will become minus 3k minus 1. Yeah, all good? All over, what's the denominator? 2/3. Okay. Now that dividing by a fraction, that 3 is going to come up the top. Yes? So that's going to become 3 to the k plus 1. All over 2. So, happy with that? So far so good? Okay, last bit of index laws here. What are you going to get when you put those two together? There's k plus 1 here. and a minus 3k minus 1 here, what will you get? I'm adding these indices together, right? So k minus 2k will become minus 2k. And then the 1 and the minus 1 cancel. Right? So I'm done. All over 2. There's my answer. Okay, so there was by formula. Right? Now let's compare that to doing it by first principles. Where does first principles start? It starts up here, right? What would I do? Multiply by. Now, here's an interesting thing, okay? What would we normally multiply by? Last time we multiplied by 2. Why did we choose 2? Because it was the ratio, right? So here, following the same process, you multiply by a third. Now, here's the interesting thing. It'll work out fine if you multiply by a third, okay? We'll get there, okay? But I just, I'm a bit discriminatory. I just don't like fractions, okay? So I'm going to multiply by 3. Now, you're like, hold on a second. 3 is not the ratio. Or is it?
It's the reciprocal of the ratio.
Now, because it's the reciprocal, right, I actually can use 3. Can you see why? Remember a series, right? The order is there, but I can turn it around backwards, and it's still going to add up to the same thing. And I'm only worried about what it adds up to, right? So therefore, if I turn it around backwards, the ratio is not a third anymore, it's 3. And that's just easier to work with. Okay? So I'm going to go 3 sigma. Okay? So what am I going to end up with? 3 to the n plus 1, 3 to the n, 3 to the n minus 1. What will my last term be? 3 to the minus 2n plus 1. Okay. Now, what do I do from here? I subtract the original series. Yes? Which terms will be left over? I'll have this guy. He's the spare. There's no equivalent there, right? All of these ones will get knocked out, and then what's left on the end? It's going to be this guy, right? Right? He's the one who doesn't get caught. That's 2 sigma, so I should just divide by 2 to get 1 sigma. And there I am. Now last time, it looked like they were about the same amount of work. It's not starting to look so equivalent anymore, is it? Right? Especially when you saw how much work it took to arrive there, and to be sure that we knew exactly how many terms there were. Okay? So I'm just trying to mount the evidence for why you want to go first principles for questions like this.